Now we're live. Okay, so tomorrow we're going to take a test, and you're going to do fine, but before we do anything, inverse or neither. So if on inverse, if it's x times y equals some number, or if it's y equals some number over x, those are both the same form, and that would be an inverse variation. The graph of an inverse variation looks something like this, which we've seen. If it's a direct variation, it's going to be y equals some a over bx plus 0. Okay? And the graph of that is just a straight line with a slope. It looks something like this, okay? Direct, inverse, okay? Now, if I take a look at these next few graphs and equations, I'm going to try and figure out which one it is, okay? So number one, x times y equals 24. Well, sure matches up to this one. X times y equals some number. X times y equals 24. This one has to be an inverse variation. Number two looks like a, b, x, but it's plus 3, not plus 0. It has to go through the origin for it to be direct. It's not, so this one's going to be neither. It has to have a 0 here. It doesn't. So to be direct, it's got to go through 0, 0. Like number 3. Number 3 is y equals a 1/2 x, and there is an invisible plus 0. And so this one does match up to direct. An example of direct variation, since spring, all of a sudden a tiny little tulip pops out of the ground. My wife is happy, and it grows 1/2 inch a day, right? But it had to start at 0, and it grows 1/2 inch a day, okay? Number 4, well, if I'm not sure what it is, one of the things I can do is I can graph it and take a look at it, okay? So if I take a look at this graph, not sure what it is, but let me see if I can get an idea. These are points at 2, 1, oops, sorry, here's 2, 1, 4, 2, 8, 3. Let's see. 2, 3, 4, 5, 6, 7, 8, 3. This looks like it's kind of like that. That looks like a square root graph. That looks like a square root graph. So I'm going to say neither. It doesn't look like that or that. This graph certainly looks like a neither, and I'm pretty sure it's a square root graph, so it's neither. 5, again, I'm not sure what 5 is, but if I graph it, I might have an idea. So I'm going to have 1 and negative 8. 1, 2, 3, 5, 6, 7, 8. 2 and negative 4. 4 and 2. 8 and 1. Oh, looks like it might be inverse variation, right? In fact, I think it is inverse variation because if I multiply them, they all multiply to negative 8, multiplies to negative 8, multiplies to negative 8, multiplies to negative 8. So it could be x times y equals negative 8. So this one's definitely going to be my inverse variation. All right. So worst case, tomorrow on the test, if you get a little confused, just graph it. Okay, 6. Am I going too fast?
Yes.
Okay. I don't mind waiting. I can wait. So it says it varies inversely. So if I see that word in my notes, I have this inverse here, x y equals some number. So I'm going to start right there with x times y equals some number. Now I need to know that number. So to get that number, I'm going to plug in negative 3 and 5. So I'll go 5 times negative 3 equals some k. I just plugged in the value of y and x, and the value of k turns out to be negative 15. So my equation is this. Write an equation. So my equation is x times y equals negative 15. Okay, that's my first part of my answer. Okay, and you can do this tomorrow. This should be very easy. Should be the easy part of the test. So then the next piece is this. Let's use our equation. If x is negative 4, let's plug it in. So I'll say, okay, if x is negative 4, what's the value of y? Well, that's easy. I'll just solve, right? Divide by negative 4, divide by negative 4. And what is that? 7 halves, negative 3.5. Right? Now I'm going to need scratch paper to do these next problems because they take more room than I gave you, okay? So I'm going to take out a piece of graph paper or regular paper, and I'll start doing 7, 8, and on and on and on with a piece of scratch paper, okay? So number 7.
Wait. You didn't make the 15 negative, the second part.
Was this supposed to be?
Oh, positive 3.5. Oh, thanks, Retta.
And I got 3.3.
Well, that's 7 half. No, 8.
Calculate says
I think I made a mistake. Don't you think so? 3.75. Retta, that's 2 mistakes.
I should get candy for that already.
Just a smarty, though. I'll get you a smarty.
I'll take it.
Here. Yeah, you can.
All right, you ready for 7? Thanks, Retta. Okay, number 7, I've got an x squared plus a 5x over an x squared plus 10x plus 25, right? Now, 1. So factor. So I'm going to rewrite this as an x times an x plus 5. I just common factored out an x in the numerator, and in the denominator, I'm going to go 5 and 5, multiply to make 25, but add to 10, so I'll go to x plus 5, x plus 5. I want to reduce, that's my goal, is to reduce, cancel. I reduce my fraction, and it becomes just x over x plus 5. Okay? That's the final answer.
That made sense.
Yeah. All right, on number 8, I'm just going to try and reduce. I mean, there's no factoring to be done, none. But I'm going to reduce, okay? So first thing I see is 6. Yeah, I'll slow down. I don't mind slowing down at all, okay? Tell me when you're ready, Paige. I don't want to go too fast. Okay, you ready? So I'm just going to reduce and cancel anywhere I can. I can see lots of places to reduce. I'll just start here. 6 goes into 12 2 times. You okay with that? And 4 goes into 8 2 times. You okay with how I did that? 5 of these x's will cancel 5 of these x's. Okay, so 5 of these x's will cancel 5 of these x's, which leaves me an x squared on the bottom. This 1y will cancel one of these y's. This 1y on top will cancel one of these y's, and I'll have y to the third on the bottom. Now there's one more place I can cancel, and you can do that on your second step We're going to do it now, but you see the 2's? I could cancel the 2's right now, which make it a little bit easier for me. So I just cancel the 2's with the 2's. What's left over? Well, there's nothing on top, but I have to have a fraction, right? There's nothing on top, but I have to have a fraction. So what goes on top? 1, because obviously 2 over 2 is 1. And then I have a x squared y cubed in the denominator. So all I do is just cancel, 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 cancel. There was no factoring to be done, so I just canceled. All right, we're going to look at 9. Okay, let me rewrite 9 down here. 9 I'm going to write as 2x squared plus 2x over x squared minus 3x times x squared minus 1x minus 6 over x squared plus 2x plus 1. Okay, now these I'm going to factor. Here we go. So, on the first fraction, the numerator, I'll common factor a 2 and an x out of the denominator of the first fraction. That will leave me an x plus 1. The denominator of the first fraction, I'll common factor out an x. If I factor out an x, I'd have an x minus 3. Times the numerator of the second fraction, I'll factor x minus 3, x plus 2, because those will multiply to make a negative 6, but add to make the middle term of negative 1. And then factor, plus 1, because 1 times 1 is 1, and 1 plus 1 is 2. Now, we're going to cancel anything on the top with anything on the bottom. We're just going to cancel. So, got an x plus 1 with an x plus 1. Got an x minus 3 with an x minus 3. I even have an x with an x. I think that's everything I can cancel, so what's left? Well, the numerator is 2 times an x plus 2. And the denominator is just an x plus 1. How am I doing?
Is that it?
That's it. Don't cancel the x's, because it's not an x, an x plus 2. Okay. You guys ready for number 10? Okay, I will. I'll write 10 down. While you're doing that, I'm going to write 10 down, okay, so we can see it. I'll do 10 over here while you're writing that down. 5x squared over a 7y squared divided by 15x squared over a 35y cubed. Okay, there's number 10. I'm just rewriting it so I have room to work, okay? Well, the first thing I see, okay. Give me thumbs up. Giselle, thank you. So I see this. So what I'm going to do is flip it, right? I'm going to flip this fraction. Invert and multiply is what they taught you in middle school. So we do the same thing. Get a 5x squared over a 7y squared times a 35y cubed over a 15x squared. Now I'm going to do the same thing that I did on 8. Same kind of problem as 8. We're just going to, there's no factoring to be done, but I'm just going to cancel, okay? Well, let's see. I can start with the 5 and the 15. You guys okay with 5 and 15? I'll cancel 5 and 15 and make it a 1 and a 3. The 7 and the 35 I can reduce to a 1 and a, let's see, doesn't that go in 5 times? Yeah. x squared with x squared, that just completely cancels. X squared with x squared is gone. And then y squared, y cubed, two of these y's, I'll cancel two of these y's, left with a y. Okay, all right, what's left? Well, in the numerator, a 5y. And in the denominator, a 3. And I'll wait for you, okay? Hmm?
10.
That's 10. Okay, give me thumbs up when you're ready for number 11. Okay. Okay, 11. I'll do 11 on the back side. So let me rewrite 11. 11 is 2x squared plus 5x plus 2 over x squared minus 1x minus 6 divided by x squared plus 3x minus 10 over x squared plus 2x minus 15. Okay? Now, divide, right? So we're going to flip this second fraction. All right, I can do that. I'm going to rewrite 2x squared plus 5x plus 2 over x squared minus 1x minus 6 times, I'm going to flip the second fraction, invert and multiply, x squared plus 2x minus 15 over x squared plus 3x minus 10. And I'll let you get caught up. And then we're going to factor, but I'll wait for you, okay? Okay, so factor the numerator of the first fraction. 2x, x plus 1 plus 2. Okay, do you remember the double smiley? Here's my 4x plus 1 makes my 5x. Okay, remember how you factor with your double smiley? The denominator of the second fraction is x minus 3, x plus 2.
Of the first one, you mean?
Yeah. Denominator of the first fraction, yes. The numerator of the second fraction should factor into x plus 5x minus 3. And the denominator of the second fraction should be an x plus 5x minus 2. Okay? And now we just get to cancel. All right, lots of stuff to cancel. X plus 2 with an x plus 2. X plus 5 with an x plus 5. Way over here even, x plus 3 with an x, or x minus 3 with an x minus 3, okay? So a lot of stuff canceled. What's left is my 2x plus 1 over x minus 2. Ta-da! That's it. Yeah, but we're going to get it done. Okay, all right. Turn the page. Okay, we've got number 12, which is x minus 3 over a 2x plus 1, subtract an x minus x plus 9 over, yeah.
Can you cancel the bottom out since it's the same already?
No, but we're adding and subtracting. So let me add an easy question. Do you have a common denominator? So we're just going to write it down. You have a common denominator. Write it down. Now we got to be careful when we subtract. We're going to go x, subtract x, right? No x's. But here's where you got to be careful. Negative 3 subtract 9 is a negative 12. Do you see I got the negative 12? Negative 3 subtract 9 is negative 12. And that's all we can do. Okay.
Wait, what happened with the x's? They cancel out.
They do. X subtract x is nothing, right? They just cancel out, right? X Subtract x is just nothing. Okay. All right, you ready for number 13?
Yeah.
Okay, let's take a look at number 13. All right, number 13 is a 5x over an x plus 2 plus an x plus 12 over an x plus 2. Okay, thank you. So, we're adding, and when you add two fractions, you need a common denominator, which we have, don't we? We've got a common denominator of x plus 2. And then let's just add the numerators. I'm going to have a 6x plus 12. Now, normally I would be done, but I think I can do more. I think I can factor.
Because there's a 1.
Yeah, I think I can factor, right? So if I factor out a 6 out of the numerator, I get an x plus 2, right? Ooh, I like this because after I factor out an x plus 2, I can reduce it. I can cancel, right? Cancel, cancel. And I get an answer of 6. Make sure you do this tomorrow, okay? You have a very similar problem. Make sure you reduce it all the way, okay?
Wait.
All right. Tell me when you're ready for 14. Well, if I subtract two fractions, they need a common denominator, which I don't have. But I think if I factor this one, it'll help. So let me factor this numerator. So let me rewrite my fraction. X squared plus 2x over x plus 2 times x plus 3 minus 1 over x plus 3. That's my second fraction. That helps. That helps quite a bit because when I look at it now, it's easier to get a common denominator, right?
Yeah.
So what does the second fraction need? Yeah, it needs an x plus 2. So I'm going to make sure I give it an x plus 2 over an x plus 2, multiply top and bottom. And then I have my common denominator. It is my x plus 2 times my x plus 3, and I'll let you get caught up, okay? So I'm making my common denominator, which is going to be my x plus 2, x plus 3. And now I'm just going to simplify my numerator, okay? So my numerator is going to be x squared plus 2x, and then I'm going to go negative 1 times x and negative 1 times 2, which is going to be a negative 1x minus 2, okay? Okay, now that's going to be an x squared plus a 1x minus 2 over an x plus 2 x plus 3, okay? All right, I think this will factor. I think that one will factor. And if it factors, it might help me reduce the answer, okay? So let me factor this one. I think it factors the numerator of my answer, x plus 2 x minus 1 over an x plus 2 times x plus 3. Oh, that reduces nicely. So then that cancels with that, and I'm left with an x minus 1 over an x plus 3. Wow, that was a hard problem. So you'll have one of those on the test. One hard problem. All the rest are pretty easy, okay? That's the hard one, okay? Okay, ready? Whisk this away. I'll wait for you, okay? Page. I know, you don't want to miss the review, so we'll get you down, okay? Are you guys ready to turn the page? I'll send you down to bed. Okay. All right, now let's look at the back side, okay? Number 15. Negative 1 over x equals x plus 2 over 1, okay? If you have a fraction equal to a fraction, equal sign, see the equal sign? I cross multiply, okay?
Oh, it's not in C.
Okay, if you have a fraction equal to a fraction, just cross multiply. So 1 times negative 1 is negative 1. X times x plus 2. Okay. And then, I'm going to go that times that times that. So I'll have a negative 1 equals an x squared plus a 2x. I need to solve for x, but I've got x squared and x. So I think I'm going to have to factor. If I have an x squared and an x, I think I'm going to need to factor. So I'm going to bring over my negative 1 and bring it over here by adding it. So I'll have a 0 equals x squared plus 2x plus 1. That'll factor, won't it? X plus 1, x plus 1. And of course, if I solve that, x equals negative 1 is my answer. Or x equals negative 1 again, but same answer twice, right? Right? Number 16. Okay, we're getting there. I will wait for you. Number 16 is kind of hard too, but we have probably maybe 2 hard problems, but all the rest are pretty easy. I mean, this is algebra 2. This is not algebra 1. We are the smartest kids in school, right? Of course we are. Okay, ready? Okay, let's look at number 16. All right, 16 is going to take some work, but I know we can do it. I have a negative 2x over an x plus 2 plus an x over 3 equals a 4 over an x plus 2. Okay, what do you think? Well, I need a common denominator, right?
Times it by x plus 2 and 3.
Yes, that would work. I got an easier, yes, totally. Red, I have an easier way to do it though.
What? I already did it.
I'm going to do that. Why am I going to do that? I'm going to bring that to the other side.
Because they have the same denominator.
Yeah. So I'd have then my x over 3 is equal to my 4 over x plus 2 plus 2x over x plus 2. Plus because I had to add it, right? So now I have a common denominator, right? These two have a common denominator of x plus 2. Retta, what you said is correct. We'll get the same answer. Okay. And now, because I have a fraction equal to a fraction, I'm going to cross multiply. That times that equals that times that. So I'm going to get a x times an x plus 2 equals a 3 times a 4 plus 2x. If I cross multiply, whoo, it's a hard problem. We can do it. We're smart. All right, I'm going to distribute both places, right? I'll have a x squared plus a 2x equals a 12 plus a 6x. Looks to me like I'm probably going to need to factor. My guess is I'll probably have to factor something. All right, so